So if you go into the sun, here are these X-rays. They have such energy. These are photons of light. They have so much energy. Energy goes up with violet, ultraviolet X-rays, gamma rays. It goes up. It goes down in the other direction. It has so much energy that you can ask, what happens if you plug that energy into the equation E equals mc squared? Just do that. If that's the energy on the left, what mass equivalent is that? And you know what you find out? It has so much energy, it could spontaneously make matter. It can make a pair of electrons on its own. So in the center of the sun, matter is being forged out of the soup of energy every moment of the sun's life. Now, what kind of matter does it make? It makes an electron and an anti-electron, a positron. Matter and antimatter pair. Antimatter is real. We invented it, not the science fiction writers. I know they've taken command of it, but it's our idea. We got to get credit when we can, because the science fiction writers can be so good at this. So when you have a high enough energy for the light, it will spontaneously become matter, and the matter-antimatter pair come back together. It makes the X-rays again. It's a soup. That's unfamiliar to us. We don't see that. Visible light doesn't do that. It's not energetic enough. It just stays as light or gets absorbed, but doesn't become energy. It doesn't become particles. All right? In the early universe, this went on big time. Big time. And it's one of the symmetry laws of particle physics that light becomes two particles, matter and antimatter. You bring them together, they become light again. It's always symmetric. Always. Yet, we're made of matter. Where's the antimatter? So there's some discussions that if an alien came and landed from another galaxy, before you shake its hand, or whatever appendage it's offering you, flip it a coin. If the alien spontaneously explodes, it's antimatter. Just always be ready to have something else touch the alien. So antimatter are perfect counterparts to matter. So something happened in the early universe to create an asymmetry. It's one of the mysteries of the early universe. 1 out of 100 million of these particle-antiparticle pairs, 1 out of 100 million of them was just a particle and not the antiparticle. 100 million. I mean, it's rare, but it happened enough to account for all the matter that we know and see and love in the universe. There's no reason to think that if it happened the other way, that we would just be antimatter talking about matter aliens, flipping them an antimatter penny. But then they probably wouldn't call themselves anti-anything, right? So yes, it's one of the great mysteries in the early universe, how it came to be that there's an asymmetry in this very symmetric process that we see all the time. So that's a long answer, but you get the full context of that. And it affects the Big Bang as well as what's going on in the center of the sun. And technically it would be called symmetry breaking, more broadly. You can Google wiki symmetry breaking, and they talk about the laws of physics that are broken by some phenomenon or process in the early universe.